All right, well, I'm going to go ahead and start. So we are jumping back into things. We're going to start our ecology unit with biogeochemical cycles. Some of these you probably have already learned about, or they may seem vaguely familiar. The notes that I sent you, technically they are already filled out for you. I went ahead and typed all of the notes in there for you. So if you have the capability to print, that could be beneficial. Otherwise, I would just do the best that you can to copy and write what you can down in your notebook if you don't have the capability to print. There is some color coding that we will do with the biogeochemical cycles. So if you have colored pencils or crayons or markers, again, can be beneficial to help learn about and remember what's going on with these 4 different cycles. Okay. So I'm just going to walk you through the PowerPoint that I made with this. Okay. So the learning objectives, again, we're going to look at how matter cycles among living and non-living parts of the ecosystem. And we're going to look at water cycle and 3 different nutrient cycles. So carbon, phosphorus, and nitrogen cycles. Those are the 4 that we will look at. Okay. So first and foremost, if you're looking at your page, you should have a picture that is similar to this, like this. Okay. So the big part is that matter is what is recycled. Okay? People like to say that energy cycles. Energy doesn't cycle. Energy flows. So matter cycles, okay, over and over and over again, but energy is going to flow, and it's only going to flow in one particular direction. Okay, it can't go back and forth. It can only flow in one particular direction. Okay, so I like this diagram of a water wheel. Oops, sorry. Because you have your energy arrows are blue, showing the direction in which the water is flowing, and the water wheel is the matter, okay? And it continues to cycle over and over and over again, allowing the energy to move in that one particular direction. Okay? There are 4 processes that are going to help cycle matter. We're going to look at biological processes, geological, chemical, physical, and human activity. And these colors that you see on the screen, blue, green, red, and orange, okay, those are what we're going to use to identify those particular processes in these different cycles. Okay. So we're going to start with the water cycle. You've probably learned a little bit about the water cycle in middle school. It's also referred to as the hydrologic cycle. Both names are accurate. Both names could be used. So the big part, if you look at the diagram, there are 2 different colors. We have biological processes that are happening, and we have chemical and physical processes that are happening. Okay? So this is a closed cycle, and it continues to go over and over and over and over again. Okay? So you have precipitation, which is some sort of water material is coming from the sky. Precipitation can be rain, it can be sleet, it can be snow, it can be hail, any form of water that is coming from the sky. Okay? So the water continuously moves between the oceans, land, and the atmosphere. So again, that closed loop. Okay? The majority of our water is located in the oceans. And it cycles through evaporation and precipitation from bodies of water to land. So evaporation brings moisture up into the air, into the atmosphere, okay? H2O gas, okay? Atmospheric water vapor, okay? And then can return to Earth through precipitation. One of the things I consider to be neat about the water cycle is that last bullet point in your notes where it says that water is never completely used up, it just changes form. So it is in a state of, it's either going to be in one of the 3 physical states. It's going to be a solid, a liquid, or a gas, but we technically never actually use up all of our water. It isn't usually found in at least one of the 3 forms. Okay? when studying this stuff, right, don't get bogged down with the details and the little minute things within the diagrams. Okay? The bulletized notes that I have for you printed on the note pages is really the extent in which you need to know. You need to be able to apply how these cycles work within ecosystems and why they're important, but don't get bogged down with all the tiny little minute details. Okay? Any questions about the water cycle?
No, not yet.
Sorry, I had my volume all the way down.
Oh. No, I don't have any questions yet.
I was like, I thought I heard something. All right. The carbon cycle is the second one. So now we have all four processes happening. We have biological, human, geological, physical, and chemical. The carbon cycle we've actually already dealt with a little bit when we were talking about photosynthesis and respiration, because we're talking about carbon dioxide a lot in this case. And so carbon is very abundant in our biosphere. So it comes in the forms of carbon gas, so carbon dioxide, C6H12O6, so glucose, which would be a solid. And then because we know that all organic molecules contain carbon, so that's our lipids, carbohydrates, proteins, nucleic acids, all those are going to be a part of this as well. And we as human beings have a tremendous influence on the carbon cycle because we are emitting CO2 gases, carbon dioxide, carbon monoxide, all these different things through burning fossil fuels and using natural resources. And the only way to remove carbon from our atmosphere is through photosynthesis. So that kind of goes back to first semester when we talked about the fact that if we did not have trees, we would not have oxygen. That still holds true because, again, if photosynthesis is the only way to remove carbon dioxide from the atmosphere, only plants can do that, whether that is a land plant or an aquatic plant. The aquatic side of that is usually where I would get a little bit confused because I never really thought of the fact of water plants, seaweed, algae, all those things actually taking CO2 out of the air that we breathe as well as out of the water and turning that back into usable oxygen. So we can't forget about the aquatic plants in that as well. And the carbon cycle is also one of the cycles that's most impacted by the greenhouse effect. And we'll talk more about the greenhouse effect and human impacts on the ecosystems towards the end of the unit. But the big takeaway with carbon cycle is, again, one that it is, I believe it is, yes, it is the only one that has all four colored arrows. It has a biological factor, human impact, geological, physical, and chemical. It's the only one that has all of those combined with it. Okay. All right. So the third one is the nitrogen cycle, and the nitrogen cycle is usually the one that students get most confused with because it has a ton of arrows. There's a lot going on in that picture. But again, it's not as complicated as the diagram is making it out to be. I think somebody just joined us. There we go. Okay. So there are, within the nitrogen cycle, again, it looks super confusing just because there's a lot of arrows going on. But this one takes out the green arrows, which were our geological. So now we are just looking at biological, human, chemical, and chemical physical contributions to this. So within the nitrogen cycle, there's some new vocabulary that comes up. More detailed pictures would give you more of that. More of that. But things like denitrification, nitrogen fixation. We may also hear the word ammonification. But that is, those are all part of the nitrogen cycle. The big thing with the nitrogen cycle is the majority of our atmosphere is made up of nitrogen gas, which is the N2 portion. And the nitrogen that is found in our atmosphere is not usable by the majority of organisms. So most organisms can't use the nitrogen gas that's naturally found in the atmosphere. So bacteria plays a huge role in this, because we have what are referred to as nitrogen fixing bacteria. And these bacteria have the capability of taking that nitrogen gas that's found in the atmosphere and fixing it more or less so that all these other organisms can use it. And the majority of these nitrogen fixing bacteria live in the soil near plant roots. So as the nitrogen gas within the atmosphere is floating around, these bacteria that are in the soil have the capability of taking that nitrogen gas, and they kind of absorb it, and they go through this whole part over here. We're talking about nitrogen fixation, and they're going to, again, more or less fix it so that other organisms can use nitrogen. The nitrogen is still going to be important, but just like everything else, a good thing is never really a good thing, because as we will see at the end of the unit, when we get to human impact, when there is too much nitrogen, we get what's referred to as eutrophication, which is, it's a really fun, long, hard word to spell, and one that's really fun to say, but can cause issues with blocking out sunlight and ends up killing off different organisms. But again, I know that this diagram is super crazy looking. And again, takeaway here, the nitrogen gas that's found in the atmosphere is not usable by the majority of organisms. And that bacteria plays a huge role in this process. And without these nitrogen fixing bacteria, we would not have usable nitrogen. So we are dependent upon this bacteria to fix the nitrogen to make it a usable form. Any questions? We're good? Okay.
I'm good.
All right, the last one. So phosphorus cycle. This the phosphorus cycle is the only one that does not cycle through the atmosphere. Okay? All the other three, so water, carbon, and nitrogen, all cycle through the atmosphere. Phosphorus cycle is the only one that does not cycle through the atmosphere. And we only have the blue, orange, and green arrows. We're taking out the physical, chemical aspect of the cycle. So we have the phosphorus cycle mainly is happening, it's not happening in the atmosphere, it's all happening basically on land, I guess is the best way to put that. Most of to deal with the phosphorus cycle is going to deal with erosion and the creation of rocks. So again, there's no phosphorus in the air that you're breathing. It's all in land and land products, more or less. And so phosphorus cycle through biological processes, which would be plants and animals are going to assist in the movement of the phosphorus through the biosphere, through different ecosystems. And we increase our flux of phosphorus when we have, again, different human activities that are taking place. So like when people are mining for different minerals, and stirs everything up and allows for more phosphorus to get into the aquatic ecosystems. So if we're these orange arrows, okay, so if this was an instance where somebody was, say they're mining coal, okay, they're mining for coal, and again, the coal particles get up into the air, and as it rains and everything else happens, okay, that stuff travels down into the water system, which I know it's kind of hard to see. The water system is behind the orange arrow, but the phosphorus gets absorbed into the water and basically starts to cycle through different aquatic, whether it's freshwater or saltwater, different aquatic systems that can cause different problems. Okay? But we also need some of it to happen because, again, we'll have the formation of phosphorus rocks as well as phosphorus soil, which is beneficial for farmers to have some phosphorus in the soil. And but again, it's the whole concept of too much of a good thing is never really a good thing. As long as everything is in balance and everything is in check, then we're usually in a good place. And with the diagrams, the biggest part is going to be able to just apply it, to understand that it's a cycle, that there are different aspects to each of the 4 cycles. So again, you have water cycle, and then you have 3 nutrient cycles. The nutrient cycles are carbon, nitrogen, phosphorus. Let's see what else I have. Oh, and the big thing is, and that matters what cycles, energy flows. That's usually the hard one, that water wheel picture. The thing that I have for y'all for tomorrow is a video. It's a short YouTube video and some questions to answer with it. It's actually already posted. You could go ahead and do it if you wanted to. That's completely up to you. The cycles are not, I don't want to say they're not important. They are important, but there are some teachers who will harp on the cycles a lot. And I think that ends up confusing you. But again, I would be able to name the 4 cycles, know which 3 of them are nutrient cycles. So carbon, phosphorus, nitrogen are the nutrient cycles. Okay. And that phosphorus is the only one that doesn't flow through the atmosphere. Okay. And that carbon is the one that has all 4 of the processes. It has biological, chemical, physical, human, and geologic. If anything, the carbon cycle would probably be the one that you'd see most frequently on a test, because they're going to want to tie in photosynthesis and respiration. Just knowing that photosynthesis is the only way to get carbon out of the atmosphere, and particularly carbon dioxide, which we can't breathe. We need to have that converted into oxygen, and the plants do that for us. Those are the biggest, in my opinion, those are the biggest points. Because I know some of the gifted teachers will like really go into detail on the nitrogen cycle and phosphorus cycle. In my opinion, again, the biggest thing with phosphorus is it's the only one that doesn't enter the atmosphere. In nitrogen, if the bacteria is not there, the nitrogen cycle is not going to work. We are dependent upon that bacteria to fix the nitrogen so that organisms can use it. Okay. Any questions? Again, that shouldn't be too difficult. Again, this is recorded on my end, so I will post it on YouTube, on my channel. I'll put a link on eClass, and then again, I'll be doing this again about 1 o'clock. But if y'all don't have any questions, as long as you have the notes in some aspect, whether you should copy the notes down into your notebook from what you see on the page that I sent out, or if you have the capability to print, you can print. if you want to keep putting them in your notebook, that's fine. That's what I did. I just printed them out and put them in my notebook like I normally would. I know that y'all don't have a tab. I apologize. Although if I knew this was going to be the case, I would have sent tabs home, but didn't know that this was all going to happen. So there, for the remainder of the time, there'll be a couple days where it's just notes like this, where there's not really a whole lot for you to do. Just, again, try to get the notes, read over them. But it shouldn't be as labor intensive as the previous 2 weeks. So unless you have questions for me, I'll let y'all get about your business and do what you need to do, and I'll go teach first grade math.
Sounds like fun.
Oh yeah, so much fun.
I don't think I have any questions. Let me check over my extra notes that I wrote down.
I think I'm probably just gonna print out the notes and then go over them.
Yeah, that was my thing. Is I know a lot of you hate writing the notes down. So instead of like leaving it blank, I just went ahead and typed all the answers in. And I was like, okay, that way they just have it. They just have the notes.
Yeah. Yeah, I don't got any questions. Easy enough.
We have a key. I don't have any questions.
Okay. Well, it was nice to see some faces.
I didn't realize I had my.
They're cute and all, but I'm kind of tired of looking at them. All right. Well, I'll be around. If you have any questions, just shoot me a reminder, whatever. I'm here.
Yes,
Cool.
ma'am.
All right. Bye.
Good day.
Bye.